Welcome to the Math 105M exit exam review. So I'm going to go through these problems 1 through 27. They reflect the problems on the final exam. So you should be prepared for them. If you can do these problems, you'll be okay. Some of them are difficult, but most of them aren't that hard, as all things considered. Problem 1. Multiply. There's two binomials, x plus 2y times x plus 11y. Okay, I'm at a car dealership getting a new airbag put in my car plus an oil change. So if you hear that awful music in the background, that's what it is. Now here, what we do with this equation is, this is basically like a fancy distribution. We multiply the first term times the first term times the last term, the second term times the first term, the second term times the last term, then we add everything together. So let's get started. We have x times x, x squared, x times 11y would be 11xy, and now we have 2y times x would be 2xy, and 2y times 11y, which would be 22y squared. Okay, so now we need to simplify it. Comes x squared plus 13xy plus 22y squared. As you can see, the answer is the same as answer C. Problem 2. Write an equivalent expression by factoring out the greatest common factor. Okay, so our problem is 24 m to the 9th minus 54 m to the 4th plus 60 m squared. So we're going to look at this and say, well, what is the most we can take out of it? And it looks like 6. You know, it doesn't hurt to look at the answers and see what they took out of it. You know, it looks like the most they took out was 6m squared. So can we do that? Yeah. 6m squared is good, because the most we could take out, you notice there's m squared. This is m squared over here. So you can't take m to the third power out of that. So, okay, so I'm going to take 6m squared out of everything. So we'll write 6m squared. And I'll put parentheses. Now we'll divide that 6m squared into each term. So we'll start with the 24m to the 9th. 6 into 24 is 4. M squared into m to the 9th is m to the 7th. Then it's going to be minus the next one. 6 into 54 is 9. M squared from m to the 4th would be m to the 2nd. And then we have plus 6 into 60 is 10. And m squared is 1. So we're done. That's the answer. Problem 3 is write an equivalent expression by factoring. If you look at this, you can see that you can't factor something out of every term. So you can look and see if there's terms we can combine, or what we can do is we can group, factor by grouping, because it's already divided up for us. Chances are we just need to regroup it. So we'll write 6x to the 4th minus 15x squared, and that's plus 10x to the 2nd the stylus, doesn't work that great. So minus 25. If you're wondering why this looks so crappy. All right, so I'm going to group this batch and this batch. See what I can factor out of 6x to the 4th minus 15x squared. Well, I can factor out a 3, and I can factor out x squared. So we'll do 3x squared, and then 3x squared into 6x to the 4th will be 2x squared, and 3x squared out of negative 15x squared will be just a negative 5. Okay, then from the next batch, the only thing we can factor out of that is 5. So 5, divide that into 10x squared, and we'll get 2x squared. And 5 into 25, negative 25 is negative 5. Okay, so then we look at it and we see that we have these two factors are the same. So that's good. We can factor those two out. So we can put 2x squared minus 5, and we factored that out of 3x squared. Whoops, no, we didn't factor it out of that. Hang on. Factor that out of, yes, did I say 3x squared? 3x squared plus 5. So our answer is 2x squared minus 5 times 3x squared plus 5. And ignore this little dot here. Number 4. And this is another factoring thing. Now this is 3x squared plus 13x plus 12. Now this is going to be another one that's factored by grouping. Because if you look at the a term in your quadratic equation there, it's a 3. And we can't factor 3 out of the whole thing. See, so we're going to be regrouping. The first thing to do, though, is to look at the answers on this one. You get a good idea of what we're going to be grouping it into, right? So let's look at them. Look at the answers here. So there's one is x plus 4 times x plus 3. Another is an x minus 9 times x plus 3. Then there's 3x plus 4 times x plus 3. And then there's 3x minus 9 times x plus 3. So the two with the 9s and the 3s aren't going to work, because if you multiply those last two terms, you get a negative 27. And so that we don't have a negative 27, we have 12. So it's got to be either A or it's going to be C. And it's probably going to be C, because our first term in the quadratic has a coefficient. See, so our answer is probably going to have a coefficient on one of the terms. But let's go ahead, and since I think it's C is the one, we could multiply that out and check. If it multiplies to 3x squared plus 13x plus 12, well, we could just use that without going to the trouble. Okay, but let's just try it. So 3x times x is 3x squared. 3x times 3 is 9x. And then we have 4 times x is 4x. And 4 times 3 is 12, if I can get it in there, which sort of. And that's supposed to be 12. All right, so we can see that we simplify that. We get 3x squared plus 9 plus 4 is 13x plus 12, which is what the original quadratic is. So obviously that's the answer. Now I'm going to show you how to do it the other way. So if you look at the quadratic, it's 3x squared plus 13x plus 12. So we're going to start out by multiplying the A term times the C term. 3 times 12, we get 36. Okay, so now we're going to factor that, and the two terms we get from it have to multiply to 36, but they've got to add up to 13. So what two terms will do that? So I think, well, 12, no, can't go 12 times. How about 4 times 3? That's what actually the answers have 4 times 3 in them. So we'll go, we're not going to go 4 times 3 though. Oh, that doesn't make sense, does it? We're going to go 9 times 4. And why, you ask me? Well, why 9 times 4 after I was talking about all of this stuff about 3 times 4? Because 9 times 4 will get to 36, but 9 plus 4 is 13. See, so we're going to divide the 13x up into 9 plus 4. So let's do that. We have just rewrite the equation, or the quadratic. 3x squared plus, instead of 13x, we're going to put 9x plus 4x, because they equal 13x, and then plus 12. And now we're going to do what we did in that earlier equation. We're going to group it. We'll group those with these. And we'll group these in these two groups. Okay, so we're going to factor out of those two groups, right? So we can factor out 3x out of the first one. 3x times, or 3x into 3x squared is just x. 3x into 9x is 3. Okay, we got our first one. And the second one, the only thing we can factor out of that is 4. And that gives us x plus 3 also. See, so now we can factor out the x plus 3, and that leaves us with 3x plus 4, which is this, you know, you switch them around. That's the same thing, so it's c, just as we saw before. You don't need to go to a new page for number 5. We have plenty of room. So we have x squared minus 6x plus 9 equals 4. So now we have an equation with a quadratic in it. So we have to get the quadratic equaling 0, then we factor it, and then we find out what the solutions are, what x equals. To find out what x equals, we have to make the quadratic equal to 0. So in this equation, we'll add a negative 4 to both sides to get rid of the 4 and make it 0. So if I add a negative 4 to 4, I get 0, and that equals, and a negative 4 plus 9 is 5, so it gives me a 5 here, and then I've got whatever else is left as x squared minus 6x. Okay, so now I look at my middle term, it's negative. So I'm going to have, and my c term is positive. So the two numbers that multiply to get that c term have got to both be negative. Otherwise, it's not going to be positive, and we wouldn't be able to get a negative middle term. So what two numbers will multiply to 5? Just to notice, there's no exponent on our first term, so we don't need to do that grouping thing. So we just have to figure out what two numbers will multiply times each other to get 5, and also add up to negative 6. So since we know there are going to be two negative numbers, it's 5 times 1. There. That was a nice break from listening to my voice, wasn't it? And our answer is 5-1. Okay, here we'll distribute and simplify the equation up above. Add a negative 4x squared to both sides. Then add 16x to both sides. So that gives us x squared plus 6x plus 8 equals 0. So now again, we don't you can still, I'm still at the Toyota place. So we don't need to worry about regrouping. We just look at the 8 and the 6x. So 2 times 4 equals 8, and 2 plus 4 equals 6. So that's what we've got here. We've got x plus 2 times x plus 4. So the answer to this is going to be, what does x equal? And what, you notice if we equal to 0 and then we subtract add the negative 2 to both sides, or add the negative 4 to both sides, we're going to get x equals a negative 4 and a negative 2. And a negative 2. Number 7 gives us the difference of two cubes. So here we have 64a cubed minus 125b cubed. We have to remember that this is in the form of a difference of two cubes, and I'm going to show you what that looks like. So if we have a cubed, a to the third power, a cubed, minus b cubed, it'll turn out to be a minus b times a squared plus ab plus b squared. And you're wondering, well, how can I remember that? Well, notice that when it's the difference, that the difference is going to show up in the first term. So it'll be a minus b, but the second term won't have a negative in it. So the first term has a single a, and the second term has your a and your b to the second power, and then the product of the first term and the second term. Okay. Notice in the sum of two cubes, a cubed plus b cubed, the first term is a sum. The second term, it has to have a negative in there somewhere, because when you multiply these out, so the middle terms get eliminated. A lot of the middle terms get eliminated. Well, all of them do, see, because you end up, if you multiplied a plus b times a squared minus ab plus b squared, you're going to get a cubed plus b cubed. So there's a whole bunch of middle terms that get eliminated, and that would not happen if there was not a negative. So both of them factor out where you're going to have a negative somewhere. And so when you're factoring the difference of two cubes, the negative is in the first term. See, difference, negative, a cubed minus b cubed, you get the first term is a minus b. And it's the sum of two cubes, you have a cubed plus b cubed, the first term is a plus b. But the negative's got to be somewhere, so it'll be in the middle term of the second term, the middle term of the second term, or a negative AB. Okay, so here we don't have we have a cubed and b cubed, but we also have a number times it. But that's all right. We'll look at it as one number. So the 64, what is that a cube of? Well, it's the cube of 4. So we've got 4, and then we've got the a. See, so it's the cube root of that first term, right? Okay, and then it's going to be minus the cube root of the second term, which is the cube root of 125 is 5, and the cube root of b cubed is b. Okay, having trouble with the stylus as usual. Okay, so then the second term of our factors will be 16, because it's the square now of the cube roots. So it's 16a squared, and then the middle term is an addition. It's the first term times the second term, but it's a plus. So it's going to be 20ab. And then the last term is going to be plus the cube of that last term. If I could get this plus in here, I'd be happy. Okay, so that will be 25 b cubed, if I can get that. Ooh, I did. I know that looks pretty sloppy, but that's the answer. Maybe I should write it again if I dare. That was almost better. Okay. Okay, number 8. Here we have 32a to the fourth b minus 50b cubed. Now, at first glance, it looks like it's going to be another one of those differences of two cubes, but is it? See, the first one isn't a cube, unless we do it as the cube root of 32 and the cube root of b. So that would be a real mess. So that's not what's intended here. And if you look at the answers, it's not. One way to solve this, and the previous one, is to multiply out the answers and see which one comes to 32a to the fourth b minus 50b to the third. Of course, I would prefer to factor out what I can. So let's start with that. The only thing I can see factoring, I look at the two numbers, 32 and 50, and I say, well, the 4 doesn't work. You can't divide 4 into 50 so evenly. So it looks like 2 is the number we need to use for our numerical factor. Whoops. Okay, so we got 2, and then what variables can we factor out? And the only one is b, because there's no a in the second term, right? So 2b, we'll factor that out. So factoring 2b out of the first term, I get 16. And I still keep the a to the fourth, and the b is gone. Out of the second term, factoring the 2 out of the 50, I get 25, and the b out of the b cubed, I have b squared. Okay, so now it looks like I have the difference of two squares, because the first 16 is the square of 4, a to the fourth is the square of a to the second power, 25 the square of 5, and b, of course, b squared is the square of b. So that's what I'll use, the difference for the difference of two squares. So we'll go 2b times 4 a to the second power plus 5b and that will be times 4a to the second minus 5b. You can compare this to the difference of two squares if it was just like a squared, too close to the top, minus b squared. Because that would be a plus b times a minus b. Number 9, find the function value. So it says find f of negative 5 when f of x equals x minus 4 divided by 6x plus 6. Alright, so this is an easy one because this is just a plug-in. We're going to plug negative 5 in for x, both here and there, and we'll just see what we get. So we've got x minus 4, so that'll be a negative 5 minus 4 divided by 6x plus 6 would be 6 times a negative 5 plus 6. Now we just simplify it. Negative 5 plus a negative 4, or it's a negative 5 minus 4 is a negative 9. Divided by, and we use our order of operations, we have got to do the multiplication first, right? So we get a negative 30 plus 6. Okay, so still have the negative 9 on top. I'm going to just rewrite it down here. Negative 9 divided by negative 30 plus 6. But a negative 30 and a positive 6, we subtract them, we get a negative 24. Negative 24. Okay, so we can reduce that. We can divide negative 3 into the top number and the bottom number. Negative 3 into negative 9 is 3. Negative 3 into 24 is 8. So our answer is 3/8. Alright, number 10 says find the function value provided it exists.
Tommy 107, please. Tom 107.
Okay, so this is the function value is f of 4. So we just plug in the 4 for all the x's in that thing. So we've got 3 times x cubed, so I'll put a 4 in here. The third power plus 3 times x squared, so it'll be 4 squared here, divided by x squared, so 4 squared, plus 8 times x, which will be 8 times 4, minus 5. Now, I know I have to go slow because of the stylus and also because I'm just kind of doing this off the top of my head. So if this is driving you crazy and you know these problems, skip ahead to, you just skip to the problems you need experience with, right? One also, look at this. It says find the function value provided it exists. Well, it's like, why wouldn't it exist? And it wouldn't exist if for some reason it made the denominator 0. If the function made the denominator 0, then that value doesn't exist in the function as a value of the function. So, all right. So now we're just going to simplify this thing. So we'll use our order of operations. So of course we'll do the top and the bottom separately because it's like they're grouped. It's like parentheses in a way. And then we look inside that group and we say what what do we do first? And of course we do the exponents first. So I'll start over here. We've got 3 times 4 to the third power. So 4 to the third power is 64. So we do that first. And we copy everything else in that we don't touch. So I'm not messing with the 3 here. So I'll just put it back in. 4 to the second power is 16. Okay. Alright, now going down to the bottom, looking at that, I've got 4 to the second power. So I'll put 16 there. Okay, and then I could do since I've already done the 16, I can do the multiplication, which would come next on the bottom. 8 times 4, 32. And then minus 5. Now we just continue simplifying. So we have 3 times 64. So 3 times 64, whoops, 192 plus 3 times 16, 48. And that's divided by 16 plus 32, or you could do 16 plus a negative 5, whichever you prefer, as long as you add all those together as signed numbers. Otherwise you should do it left to right. Start with 16 plus 32, 48 minus 5. Thank you. I'm all set to go. Alright, might as well finish this problem though. So 192 plus 48 is 240, and then 48 minus 5 is 43. So the answer is 240 divided by 43. Number 11. Write in simplified form and list all restrictions on the domain. Okay, so we have f of x equals 49 minus x squared divided by x squared minus 14x plus 49. Okay, so the first thing we need to do is we need to factor this thing, right? So get the pen working again here. Okay, so 49 minus x squared, difference of two squares, so that's 7 plus x times 7 minus x. Okay, and in the bottom we've got x minus 7 squared, but I'll write them both out. X minus 7. Right, because two negative 7s add up to negative 14, which is our middle term, and then negative 7 times negative 7 is 49. Now it looks like we don't have any matches here, but actually we do. We just have to rearrange the negative and one of the x minus 7s on the bottom to make it 7 minus x. Okay, and we can do that by, I'll put this, make this negative here, whoops, this negative here, and then I'll make this negative and this positive. So I've just actually put the negative on the outside. So now it's the same as the one on the top. So I can cross this one out, and I can cross that one out. And then I can multiply through actually with this negative on the other one. So I've got 7 plus x divided by a negative of x minus 7, which, I'll go back to black, which would give me, I'll put over here, 7 plus x divided by 7 minus x. That's one way to do it. Now remember that I'm supposed to state the restrictions on the domain, so actually we have to go back here to see what those restrictions were. Okay, and so we've got to, we can't have a positive 7. So this is the simplification, and x cannot be 7. Number 12, determine the domain of the rational function. Okay, so we have f of x equals x squared minus 49 divided by x plus 8 times x minus 5. Now we don't have to do anything else but look at the denominator here. Seeing that there's x plus 8 and x minus 5, we can see that the domain does not include a negative 8, nor does it include 5. Can't include negative 8 or 5 because that would make it 0. So now we need to write the domain of the function, and we need to put it in interval notation. Now all the answers, this is a mistake I made, all the answers I've put in here are in interval notation, but I forgot to put the unions in, you know, those U's between them, because they're a union of these different sets. Okay, so anyway, so we'll put them in now, but remember that these answers don't have the unions in them. Okay, so all real numbers except for negative 8 and 5 in interval notation. Start with an open paren with negative infinity, and that's going to go up to, but not including negative 8. And then that's going to be unioned with the distance from negative 8 to 5, but not including negative 8 and positive 5. And then unioned with open paren 5, not including 5, and going to positive infinity. And that's the answer. Number 13. It says, perform the indicated operations and if possible simplify. Recall that multiplications and divisions are performed in order from left to right. Okay, so I have to keep that in mind. And now I'm going to make it bigger. So now here we have three rational expressions. The first two are multiplied, and the third one is divided. Okay, so the first thing we have to do is we have to factor all of them. So let's go about doing that. We've got x squared plus 11x plus 28. So 28 is 7 times 4, so that adds up to 11. So that's good for that one. Down below, x squared plus 7x. We can't factor that like we did the one above. We have to factor out an x out of that one. 7x has nothing to do with that. The x squared plus 8x plus 16. Well, we've got, what makes 16? Well, 4 times 4. And 4 plus 4 equals 8. So there we can factor that into x plus 4 squared. Okay, and then we have the division of x plus 7 divided by x plus 4. So why don't we just do the multiplication part first, and I'll bring down the division section. So we can cross out what we can cross out. So we can get rid of this x plus 4 and this x plus 4. We can get rid of this x and this x. They cancel into each other. What else we have? Oh, here's an x plus 7, x plus 7. So all we have left here then is we have 7, whoops, 7, there we go, 7 over x plus 4. And now that's divided by x plus 7 over x plus 4. But you know, in division by fractions, we're going to invert that. We're going to go use the reciprocal of x plus 7 divided by x plus 4, because multiplying by the reciprocal is the same as dividing by the current number. So we're going to do that. We're going to invert it. So we have 7 over x plus 4. Notice we invert the divisor. Okay, and then we'll reinvert that. We have x plus 4 divided by x plus 7. Okay, so now we can cross cancel the x plus 4's. And that gives us 7 divided by x plus 7, which is A. As it turns out, it's right there in front of us.